How many of you are familiar with the Nintendo Wii that was originally known as the Nintendo Revolution? Okay, the Nintendo Wii brought motion and location-based user control of the user interface and of games running on the user interface to game consoles. The Sony PlayStation Move, which I'll talk about in more detail a little bit later, to some degree, albeit I think for most end users in a very similar fashion, brought that same sort of a user interface to Sony's PlayStation 3 platform. With Kinect, Microsoft took a different tack, and with the Kinect peripheral, you are the controller. There's no need to hold on to, and I'll grab it later, there's no need to hold on to a separate game controller. You, by virtue of your voice, by virtue of hand gestures, by virtue of other body movements, directly control the game console. So in early October of last year, about 1 month before Microsoft launched it into the retail channel, Microsoft executives said that they would probably sell about 3 million Kinects before the end of the fiscal quarter, which ended December 31st. About 2 weeks after it started selling, on November 5th, I think it was, they upped the sales forecast to 5 million. And at the Consumer Electronics Show, Steve Ballmer announced that, in fact, in the first 60 days of sale, they'd sold 8 million Kinects. So a pretty steep ramp up from the original estimate. I'm sure a bit of a nightmare both for Microsoft's manufacturing partners and suppliers to respond that quickly to such a steep ramp.
So I've got the outer shell off just so these are, the microphones are in this assembly. I've disconnected, there's a microphone connector cable here, and there are lens covers for the cameras. What you're seeing here is this is the infrared projector, and I'll show you how that works in a minute. And then we have an infrared camera and a standard RGB camera. And they've got a 2-layered PCB, and we're going to go through all the components on the PCB here in a minute. And interestingly, if you saw how the entire case was put together, like this, the fan blows air across the PCB and through the other side. Microsoft was very concerned about cooling with this unit. And I don't know about you, who has an Xbox 360 or has had one at one point? Okay, and of you, how many of you know about or have personally experienced the red ring of death? Okay, wow, so just about as many. All right, so the red ring of death was a Microsoft's Intel moment. After you have your Xbox for a while, it overheats. And what's actually happening is the solder between the graphics chip and the CPU and the main board, we were getting cracks in the solder. And so Microsoft had, at their expense, and it wasn't a $700 million mistake, I don't think, like Intel's, it was a couple $100 million mistake. And they had to have people mail units back in. Well, that worked fine while the units were under warranty, but once the units went out of warranty, Microsoft was happy to just tell people to buy a new console. The thing is, it's actually a pretty easy fix. We sell a kit. You can, if you reflow the solder or just clamp, we'll use bolts to clamp the processor back down. You have a heatsink on top, and you can actually fix a lot of these units. So Microsoft is doing their next version Xbox product, the sensor module, and they are very concerned about heat dissipation, especially because the infrared transmitter actually puts out quite a bit of heat. They were concerned about high humidity, high temperature environments, people having it on top of already hot TVs. And so I think they overdid the cooling a little bit in this unit.
You know, a lot of the ICs that you're going to see in the next few slides are probably not terribly surprising to you. It does interface to the system over USB 2. And in the newest generation Xbox 360 console design, there is a dedicated bandwidth, high power USB 2 port specifically for Kinect. There's also a fairly complex adapter cable that allows it to be used with prior generation console like the one that I own. There is, as you often find with Apple products as well, there is one mysteriously labeled IC on this particular printed circuit board, which I agree with Kyle is probably boot code stored in an SPI flash memory. He thinks it's probably Atmel. We don't have confirmation of that. And focus on that mysterious Marvell AP102 system on chip, which seems to be a system-wide controller. I'll talk more about that in a few minutes. The second PCB has, again, video and audio ADCs, a motor controller, and a NAND flash memory. Now, here's the interesting thing. There's another image sensor processor. Microsoft worked with a company, an Israeli-based company called PrimeSense, to develop the depth sensing technology that uses an infrared transmitter and receiver, both built into Kinect. Now, if I pop back here a few slides, this is the PrimeSense reference design. And as you can see, it has an IR light transmitter interface. It has a 320, a quarter VGA IR receiver sensor, but it also has optional inputs for a visible light sensor, as well as several microphones. Now, given that that's the case, it's not entirely clear to me why, and I'm going the wrong way, why the Marvell SoC is there as well. There are actually 4 audio microphones built into Kinect for ambient noise suppression, as well as 3D audio detection purposes for depth. So that may be part of the reason why. I also believe perhaps that Microsoft has plans for Kinect that extend beyond the console itself to possibly as a PC peripheral, where you don't know necessarily what level of system processing power may be available. Keep in mind that with a console, no added feature that you bring to the console can negatively impact frame rate or response time. For anybody that's doing any sort of a fast twitch game, those are the things that you do not mess up at all. So I suspect that the Marvell SoC may in part be there to do an increased level of pre-processing, thereby unburdening the console. Also, keep in mind you have limited USB 2 bandwidth available, and that has to not only handle the data coming off of this, but also coming from headphones, coming from other controllers that might exist, also coming potentially from the wireless networking adapter. So again, the more you can do here, the less you have to do at the console and the less data you have to send to the console.
So what Kinect does is creates a depth map. It's projecting infrared dots onto you. It's projecting a grid. And if I point it over at Brian here, you can see it has an idea of how far away everything on the table is. And there's Brian. And if I go back over, you can see it's constructed a physical map of the room, combining what it can see and also the depth involved. So this is phenomenal for robotics. If this is the first low-cost, reliable depth mapping system we've ever seen, and so people are putting these on top of like quadcopter drones and building fully autonomous drones that can fly around the room and detect obstacles where before they had to have expensive, heavy laser, LiDAR systems or inaccurate infrasonic sensors. This is low cost, a little bit high CPU demand, but that's okay. We can throw silicon at problems these days, right? So what the Xbox sends, or what Kinect sends the Xbox is 2 streams, a depth map, 640 by 480 depth map, and a 640 by 480 image map, and then this software is then combining the two. And it's pretty phenomenal. You can even see, those of you in the audience, you can see it's picking up exactly where you are in the room, and it's low resolution, but pretty dang cool. So I was excited about this, and this is the software that I'm showing you. This is a Mac software called Kinect Viewer. This is based on an open source project, and I actually have the source code here for working with the Kinect. So if you're a hobbyist and you want to, so whoever gets the Kinect, if you want to hack on it, there are open source libraries that let you basically start where this program leaves off and build all sorts of interesting applications on top of it. Really a phenomenal opportunity. This is really just the beginning. And I think inexpensive sensors like we've seen on the iPhone with accelerometers and gyros, and now sensors that tell us more about the world around us, are really going to open up a lot of innovation. The key is getting people, hardware hackers like me, and the guys who are here before me, and the academic community, giving them the opportunity to play with this stuff. This has been available at the $10,000 to $20,000 price point with laser sensors for 20 years, but we haven't seen the amount of innovation happening until the last few.
The only other IC that I'd like to highlight on here that whose presence and purpose I found really intriguing is the accelerometer that is in the upper left corner of that PCB in the orange square. My Kinect is mounted to the top of my LCD TV via a third-party mounting bracket. And it's a little bit cockeyed. Okay, it's not exactly perfectly aligned on top. Also, when one jumps around, well, playing with the Kinect games, one tends to shake the Kinect device a bit. So for both reasons, that's why the accelerometer is there, to detect out of perfect alignment conditions and compensate for them in the software.
The accelerometer is almost just a value add. It's a almost Apple-esque thing to do, to over-engineer it, build something extra into it. And the Kinect can not only sense where you're at, but also how much it's moving in relation to you. That's really interesting to just toss that in there almost on a whim and say, well, yeah, that's inexpensive, we can do that. And I think as more and more inexpensive sensors come out, the price comes down, we're going to start seeing people throw sensors into all sorts of designs, whether it's directly relevant or not.
This may be the first time that the traditional razors and blades sales model has been extended to a peripheral. And what I mean by that is that if any of you who followed the console business for a while know, you sell the base console at or below its cost to the manufacturer to get the consumer hooked. And then you hope you make up your money and then some by selling lots of high profit margin content, whether that be games or nowadays movies and things like that. The estimated bill of materials cost for Kinect is, I've seen estimates of upwards of $50 or more, somewhere in the range of $53, $54.
Which is really expensive.
Which is quite expensive.
Or $150 price point device.
Right, so you add in R&D costs, you add in marketing costs, licensing fees to PrimeSense, manufacturing cost, distribution cost, the cost to develop the game that's bundled with the peripheral, and the inevitable retailer markup, and you're probably at or above $150 at that point. So one would think that there's probably a cost reduction path for Kinect, as there has been for the Xbox 360 console itself. Other comments and questions. The infrared map is quarter VGA, even though a VGA sensor is used in the design. Again, I don't know whether that was a means of minimizing USB bandwidth or if that is planned to be upped in the future.
So I basically got this disassembled. I was going to see if any of you had questions about the internals of the Kinect. We have some other stuff that we want to show off, but I want to take the opportunity just to point out things here. This is just LED, status LED. This is the infrared projector. And we already showed you what's on the board. So this is relatively simple. One thing that's kind of interesting, and I think I'll take apart here, is the base unit is, I think, one of the more fragile components in the Kinect. It is, it's like a little clockwork in here. And if I get the screws out, I wanted to do this on camera because the pieces are so small that they're probably going to fall out and maybe we'll never see them ever again. So I've got this open. Can you see okay? Here we go. So there's the bottom, and then this little stand comes out, and what we have here is a little itty bitty motor with a linear drive shaft, and then converting it to, and if I turn this guy, now let's see. So this is what allows the Kinect, and the whole Kinect pivots up and down. So what happens if you have a Kinect and you've turned it on, as all my springs and cogs go flying here, it pivots to point directly at you. It's got a relatively limited sensor range, and that's compounded by the low resolution of the cameras. It doesn't have a very big visible range, as you saw from when I was pointing it at you guys. So it really needs to be pointing directly at the center of your mid-body so that it makes sure it can see your feet, it can see your head, and also if you're jumping a couple feet in the air. So it really wants to be centered on you. And so what happens, the Kinect initially, it scans the room. It pivots left and right and up and down, figures out exactly where you're at, and then it homes in on you. Sort of like the Pleo does, actually. The Pleo will look around and figure out where its owner is and home in and follow its owner around. I think this is the very beginning of home automation and the machine's understanding where you are, what you're doing, and what you want to be doing. And they're there to help facilitate that.
Let me pop over for a second, show the IR beam pattern. There we go. There's the IR beam pattern.
Yeah, so you can barely see this. This is, if you look, if you're in a room and you put on an IR filter on your glasses, or this is with an IR camera, you can see this is the beam pattern that's projected. And I know it's a little hard to see, but it's basically it looks like the Matrix. It's a grid of green dots. And the difference in distance between each of those dots, if it were a flat wall, it would be a fixed distance between them, but because this is you're always in a space where the dots, you're farther apart than the things behind you, increases the space between the dots, measures the distance between each of those dots in silicon very fast, and then sends the result to the Xbox. So the Xbox itself doesn't have to do a whole lot of work. It's interesting the amount of RAM they put in this. And I've also heard that the audio processing is a little bit overbuilt. There are 4 microphones, and Kinect, and this is something that Microsoft layered. The PrimeSense technology is primarily visual. The Kinect's microphones allow it to also not only pinpoint somewhat where in the room you are, but they can isolate you from background noise. And so you can be watching a football game with the ESPN Zone app that's in the Kinect store, and at the same time talk to it, and it will differentiate you from the background noise that it's putting out, as well as everybody around you at the Super Bowl party. We haven't seen that level of audio isolation in a voice control app before. And I don't know to what extent that is done in hardware on the Kinect versus software on the Xbox, but it's really pretty impressive. That combined with Microsoft and the hundreds of millions of dollars I think they put in over the years in voice recognition technology. The Kinect, I feel, was a little bit of a moonshot on Microsoft's part. It was a lot of different things that they had to pull together. Not only the hardware aspect of it, which is interesting, but also all of these algorithms that they've had in their R&D labs for years. There aren't that many other companies that have full-on kinematics detection, audio, speech recognition, and the entire gaming platform to tie it together into something that works for the consumer. And it really, really works. It's very impressive. My personal complaint with it is that I thought it was going to be more of a social experience, and a lot of the games tend to be turn-based because the resolution and the viewing angle is so limited that there are only the more simple games allow multiple people to play at once. And I'm not sure if that's something where the software will get more sophisticated and some of the games will, some of the more advanced games will support multiple players or not. For example, one of the more popular games is Dance Central, which you get to dance like Lady Gaga up on stage. I'm not going to dance for you. I'm terrible at it. But you can only do one player at once, and so it has one person go in and it rates you, and then you go off and the next person dances. And it would really, really be cool to have either multiple Kinects and you in different parts of the room, or to see the visual resolution increased in Kinect 2 to the point where you could have 3 or 4 people dancing at once. Microsoft's marketing, when Kinect came out, they hired a whole bunch of dancers and took over Times Square and had hundreds of professional dancers on Times Square. And I'm curious if they all had their own individual Kinect, or if it was mostly theater and there wasn't a lot of actual hardware interaction going on there. Question? Any other questions? OK, thank you very much.